All right, Thursday. You're still learning about some waves today. We're going to read a little short text called Reading a Light Wave. Then you've got 5 questions to answer. And then I'll show on the last slide as where I want you to spend most of your time today on some wave experiments. So it'll be a lot of fun. I'll show you how to do that in just a minute. Well, let's take a look at this text first. It's called The Parts of a Wave. Some of these we've already learned, all of these we've already learned about: trough, crest, amplitude, and wavelength. Grab your space bicycle. Today we're riding a light wave. If you look at a ray of light, you'll notice that it moves up and down and up again like hills. Why does light move this way? We've not figured that out yet. Maybe it wiggles to move faster like a snake. Maybe it just likes to dance. Whatever. Either way, let's get going. I see a light wave coming across from the setting sun. Let's take a look, but make sure you put on your sunblock. Since the light waves are shaped like hills, it's easy to think about riding a bicycle up and down a light wave, like this boy in the picture here. The best part about riding light waves is that we get to start downhill. The first part of the wave drops down in a steep curve. Feel the rush as you drop down into the great dip, like a roller coaster falling down the track. When we stop falling, we're on the flat part of the wave. The lowest part of a light wave is called the trough. If you need a way to remember this term, think of pigs eating out of troughs. They need their food low in order to get to it. From the bottom, you can see the top of the wave in front of you and behind you, but nothing else. We need a better view for that. So pedal fast. With all that speed, you fly up the next hill. You can only make it about half of the way before you have to pedal hard again. Finally, you reach the top. You can rest for a second. This highest point on the wave is called the crest. From here, you'll be able to see the dips in front of and behind you, as well as the crest of those hills. What's a good way to remember crest? Well, crest is a kind of toothpaste, and you should be brushing your teeth at the top of your list. Ready? Push off again. As you race down the light wave, you notice that you're falling much farther than the first wave. You drop twice as far as the height or the depth of the last hill. How can you tell your friends just how crazy that drop was? Well, we can measure the size of a wave by you starting at the middle and either going up to the top or down to the bottom. Amplitude is the distance from the middle of the wave to either the top or bottom. The more you have to pedal with your bike, or the more you feel your stomach drop when you ride down, the bigger the amplitude. How will we remember amplitude? Well, sound moves in the same way as light, in waves. You may have seen a guitar amp. When it's really loud, it makes a lot of strong waves. With all of this rising and falling, you've ridden far away from where you started. How far have you come? How far do you need to ride to get back home? In order to measure waves, you look at the distance between a point on one wave to that exact same point on the next wave. Let's say from crest to crest. The length between the same point on 2 waves is called the wavelength. This one is easy to remember. Just put wave and length together. These new words you learned can be used to describe any wave: sound waves, light waves, ocean waves, waves on a graph, or even the waves you and a friend make while holding a jump rope and moving your arms up and down. Could we ride one of these light waves to the sun, you ask? No. The sun is another 93 million miles away. Although I'm sure with some light riding practice, you could make it to the horizon. Just keep pedaling. Well, that's kind of a science in a story form, huh? Some of those words we know that you'll be answering some questions on in just a moment. I would go ahead and answer those questions and then come back to this slide because you'll want to spend some time doing this. I have this link on the last slide that takes you to some wave experiments rather. So let me pull up what you're going to see when you click this link. You will see this right here. Okay, I can't move myself. All right, well, you're going to see this right here. So let's say we want to work with water waves first. So you click on water waves, click on it twice. All right, and then you've got this little setup here. I'm going to see if I can move myself. This isn't working on this website, but that's okay. So you've got this little setup here where you can test these waves. And so you've just got to play around with these and see what all you can do. But if I click on this little green button, you want to look for the green button on all of these. Click on the green button, and it's going to send a water drop, which starts these waves going out, okay? So you see how it's creating waves. Now over here on my chart, if I wanted to measure a wavelength, I could do that. I could have to pause the video and I might measure from one wave to the next. So it looks like these have about a wave of 2.4, 2.5 centimeters, a wavelength. Okay, what happens if I increase the amplitude? Would it change the wavelength? Pause it and see. Did it change it any from one point to the other? Looks about the same. What if I did change the frequency? That's going to be more waves per second. Yeah, there's more waves, but it looks about the same to me, doesn't it, you? Let's see if it changed. Oh, well, my little thing that. You just have to play with it and see. Now, I'm not sure what this, oh, this is a timer. So if you want your waves going, you can see how. So it's taking about a second and a half between each wave to pass. So you're checking your frequency with your timer. And this one, it shows the graph. It graphs it for you. It shows the waves there. So that's really cool, isn't it? Now you can change these. You can make it less frequent. And look what the graph changed. So they're not as frequent. Now you can also shrink the amplitude and make them little, very small waves, almost none. So play with that. And then use button down here. It gives you a different way to look at it. Okay. So anyway, play with that down here at the bottom. If you want to go do some sound waves, you're going to do the same thing. You just click the green button there and play with these. There's some different things you can do. I can't move myself. Okay, so if you click on play tone, it plays the tone. And you can hear lower amplitude, lower volume. Frequency, the higher frequency, the higher pitch we learned. Okay, well that's fun to play with. So there you go. So you can play with the sound waves, and then you've got light waves too that you can play with. So click on your green button, sending out light waves. You might want to look at a different way. So it just sends out one at a time that way. You can go to a different view of it. You can increase the frequency. You can do all those things with a light wave too. So you can experiment with this website. I think you'll enjoy it. Make sure you answer your 5 questions from that little text first about riding a bike on the light wave. Then you can come spend as long as you want doing this, okay? All righty, have fun.